We've now seen how to judge if an isotope is stable, what to look for to see which isotopes are stable. Let's look at the different types of radiation that will come out if it's not stable. First is alpha radiation, which is written as a fish kind of thing. Or let's do this first. It is 2 protons and 2 neutrons being thrown out of a nucleus. Alright, so since it's 2 protons and 2 neutrons, I forgot that 2 there, 2 neutrons, it is the same thing as a helium core. Okay, and so that would be 4 and 2. And so those are the numbers that we're going to associate with alpha radiation, is 4, 2. 2 protons and 2 neutrons. The next form would be beta radiation, and that is written as a B with a tail. And it is when a neutron splits into a proton and an electron, and the electron is thrown out. So with radiation, something is always thrown out, and whatever that is thrown out, and that's what hits you, that's what we're looking at. That's what we call the radiation. So here it's the electron that's thrown out. So when we do an abbreviation, we're going to look at the electron. Okay? The mass isn't going to change because I'm going to lose 1 neutron, but I'm going to gain 1 proton. So my mass stays at 0 for both of these. Okay, and then it is going to be a -1 here. And we'll look at an equation that kind of explains why it's a -1 later on. But these are the numbers that you should know for beta. And this is the extra symbol for beta, is that it's an electron. The third type is gamma radiation. It looks like the dying fish upside down. Okay. This one has nothing ejected. It is pure energy. It accompanies alpha and beta radiation. If you have alpha radiation or beta radiation, you also have gamma, because it is the results of electrons rearranging from when the 2 protons and 2 neutrons leave in the alpha, or when the neutron changes in the beta. The electrons are going to change how they're working, or how they're orbiting, because of the different nucleus, and so you're going to get some gamma radiation. Alright, and last is my neutrino radiation, and it's just 1, 0 over n. It doesn't have another symbol. Okay, this one is the one we're worried about the least. Make sure that you know these other 3 for this. When we write these out, what we're going to do is we're going to say, okay, I have uranium-236, and it has 92 protons. It is going to undergo, so I'm going to draw my arrow, so it's undergoing alpha radiation. So I can look at this, I can say 4 and 2. 236 minus 4 is 232. 92 minus 2 is 90, and my new element would be thorium. Okay, so my uranium is going to undergo alpha decay. It's going to lose 2 protons and 2 neutrons, and because it lost 2 protons and 2 neutrons, it is going to become thorium. So I have 2 things that were a result of this radiation, my alpha radiation and a new thorium atom. If I'm looking at beta radiation, then I can do something like boron 13. Boron has 5 protons, is undergoing, so I have my arrow, beta radiation, 0, -1. 13 minus 0 is still 13. 5 minus a negative 1 is 5 plus 1, so a 6, so this is now carbon. Okay, and again, that same thing is holding true here. I have boron, and it's going to produce two different things, a beta particle, radiation, and carbon. Alright, last, if we look at these, alpha radiation has lots of punching power. It's like your sledgehammer. It will not go deep into you, but it will burn you. Beta is your pocket knife. It will make you sick. It will get into your organs, but it won't go all the way through you. Gamma is the pure energy. It is the lightsaber. It will cut through you and cause cancer. Alright, and remember, you always have this one if you have either of these ones. Alright, there you go.